Hello, everyone, and welcome to the weekly podcast. I'm your host, Gurtej Atwal, and I have my co host, Ishtinder Sidhu, with me today. Today, we have our guest, Surinder Parag. We will be learning about oil and gas. So, how oil and gas industry is. So, Surinder Brad, he's a mechanical engineer in Bakersfield, very much engaged in oil and gas industry. Now I'll welcome and request Surinder to please share his professional as well as his educational journey with us.
Hello, everyone. Thank you, Gurtej and Shinder, for giving me the opportunity to share my professional experience. Highly obliged. Um, a little background: I did my bachelor's of technology in mechanical engineering from our prestigious institution, Guru Nanak Dev Engineering College. I was a pass out of 2004 batch. And then I worked for 2 years in a local company in Ludhiana as a production team leader, and worked there for as a director technical. Worked there for 2 years, and then I made my mind to go for higher studies and came to Fresno State, popularly known as California State University, Fresno. Was there for around 3 years, completed my Master's of Science in Industrial Technology. Um, After graduating in 2010, I worked for a year as a production supervisor in a small town called Delino. It's kind of 40 miles north of Bakersfield on 99. Worked there for almost a year, and after that, luckily, I had the opportunity to work with an oil and gas uh, consulting services company. The company earlier was TJ Cross Engineers. It was a local oil and gas company, but then it got bought out by a major company called Parsons Corporation. They have their head office in Houston. They are all over the world, 12,000 employees worldwide. Their main office in California is in Pasadena, but their oil and gas division is in Bakersfield. So I've been working there for almost 10 years now, doing mechanical and process work, which we will discuss how that goes. So this is kind of the overall picture of the oil reserves that we have throughout the world. A general conception is that oil is only in Russia, which and Saudi, which is not true. We have a lot of reserves in California as well, and you see all the dark blue places in this slide. So those are the heavily concentrated oil reserves, and USA ventured into oil reserves not that long. They have been dependent on foreign oil for a while, but now at this point they are sufficient enough that need they can go on their own. So they have enough oil production in United States itself, which includes Alaska. Alaska and Texas are the major oil producing reservoirs in US. We have a bunch of reservoirs in California as well, which not many people know. So we will discuss that in detail in a little bit.
Yeah, no, Surendra, that is the key point because always we have heard that the oil is coming from Middle East. So as you have mentioned that US and other countries, they have started drilling recently or started focused as compared to those countries. So they have greater reserve, which they are using extracting since long.
Right. I guess part of the reason is the oil extraction process in the Middle Eastern countries is not that extensive as we have in US and Canada. Canada has reserves too. In Calgary, in Alberta, they have a lot of reserves. Basically, with the advancement of technology, the wells that were dead like 40, 50 years ago, we were able to revive those wells. So the like I said, it's the production coming from Saudi is is the separation process, the extraction process is not that hard as compared to what we have here. So because we have our reservoirs are underground, they're it's not just separating oil and water as Saudis do, but we have a lot more aggressive and extensive process. So hence with the new technology, we are able to get our dead wells live again.
Yeah, Ishender, please lead us into the conversation.
So I think here we are trying to discuss the overall production of oil globally over the last 100 years or so. So,
Right.
Surinder, how do you see this? How do you see this graph?
See, if globally the oil production has increased, there are other alternative resources coming up as well. But the primary dependence of the whole world, even as of today, is on renewable fuels, which mainly constitute crude oil. Well, and from crude oil, you can get various other products through refining, but the main dependency is on crude oil. Hence, you see this graph. We have an constantly increased production over the whole century. So 1930 to 2020 is almost 90 years. So you can see the production has gone from close to 5 million barrels per day to around 73 million. So it's kind of it's a big leap, I would say.
Yeah, no, there seems to be a huge potential as new countries are extracting oil, and that everything is dependent on oil. So, and
Definitely.
yeah, so this is kind of some countries. Can you please share us so how new countries they're extracting more? So what the globally percentage wise?
See, top of the list has been Saudi and Russia, but US has been lately catching them up. So, like I said, we are getting at a point that we are self-dependent on crude oil. So, as you see, it took a little plunge in 2010, but then 510, but now we are at pace with Russia and and Saudi.
So these are all the companies that engage in oil drilling. So how do you portray this graph, Surinder?
See, if you like it's in the graph it portrays 80% of world reserves of oil and gas are controlled by national oil companies, and then there are around 15 state-owned. So if you still see Saudi Aramco is the biggest has the biggest reserves, and then you have the Iranian oil company. So they constitute almost, you say, more than a quarter of the whole production. So it's kind of they are still Middle East is still leading the game, but we are not far behind.
Right. No, thank you, Surinder. So if we talk about California, so what are the biggest companies? Like we have heard Chevron, we our day-to-day activities, day-to-day life, everybody have heard about Chevron. So let us know some other companies which do drilling in California.
See, the major players in Central Valley and Central Coast, we have Chevron, of course, and then we have Era Energy. Not many people know that Era Energy is jointly owned by Shell Oil and ExxonMobil. So basically, put it in a very simple way, Era Energy is the drilling subsidiary of Shell Oil Company and Exxon. And now there are other major producers as well. CRC, popularly known as in our language, it's California Resource Corporation, and then you have some private players as well. Berry Petroleum. You have the Crimson Resources. You have Sentinel Peak Resources, McPherson Oil, and Oxy Petroleum. So these all contribute their own share in a big way, not only in the extraction of oil, but getting people engaged in day-to-day life, for as far as jobs are concerned. And then you have secondary industries associated with all these companies. You have drilling, you have major piping. It's a lot of infrastructure that is involved. So everything is kind of clubbing in together. So these are the major companies, but then there are other secondary companies as well supporting the whole industry here.
So let's get into more of details on what actually is oil drilling and what kind of operations are involved there.
Right. So basically, put it in a very simple way, there are major type of oil and gas operations are defined into two categories. One is upstream, one is downstream. So upstream is which involves your reservoir, your geologists, your oil discoveries, oil well drilling, all your rig operations, and then your oil treatment, water treatment, gas extraction. So basically, upstream involves from extraction from the reservoir till you have a crude oil that's ready to go to the refinery. So that is the upstream industry. So I am basically involved in the upstream industry because we are actively involved in oil treatment and water treatment processes, gas extraction processes, designing the facilities, on plot, off plot. Now the downstream industry is once you have the crude oil reaching the refineries, then you have the creation of various petroleum products, which includes your LPG, liquid petroleum gas. Then you have gasoline, diesel, naphtha, fuel oil, tar, charcoal. So you have various other products. Those are those are extracted in the refinery, and then from there on, marketing it, taking it to the gas stations, taking it to the consumers. That is all the what we call the downstream industry.
Yeah, no, thank you very much. Now we kind of have the concept, we understand. So it is divided into two parts. So now just we are not aware so how the whole system works. So we cannot visualize. We just see, oh, something is extracted beneath the ground. So just give us some overview.
Right. When you go on 99 and 5, you see these small oils, moving around, and we see, okay, this is oil, but there's a lot of things that go into that. So we start from the reservoir, which is where the geology of the reservoir comes in. So we have geologists that uh, they find the oil, they find the reservoirs, then they study the soil. They know what kind of soil it is, how deep the reservoir is. So if you see this slide, I have a small portion blown out of the of a reservoir. So we have what you see on the surface is there are many layers before you hit the reservoir. So first you hit the gas, then you have an oil, and then you have water beneath. So there are in basic layman language, there are three layers. Now there are some other layers, but if in a simple language, there are only three layers. So our job is, for the role of geologist is he has to analyze the wells to identify the size, the shape, the thickness, reservoir, the porosity, permeability, how much is the hydrocarbon saturation there, what kind of equipment we need, how much is the pressure beneath, how much temperature is beneath. Uh, Porosity in simple ways is the percentage of void space within a rock. If you have a simple rock, you will see it's not, you see it has some small little holes in it. So porosity is basically the amount of empty space that we have in a rock. The permeability is how much, the ease of fluid that flows through that rock. So taking into those account, we see the porosity, we see the effective porosity, the total porosity, we see the permeability, and then the geologist finalizes, okay, this is a good reservoir, and then let's start extracting oil from there. So once that is done, then the identification of various reservoirs is done. Then you have the drilling coordinates are specified, and then we have the drill rigs coming in, drilling, and then the extraction process happens.
So another point on this one, as we see that there is oil. So when it's extracted, is it filled with something else, or it's extracted and there's a void space then?
No, it is. So there are various kinds. We do it in for example, in Lost Hills, most of the reservoir is it's extracted through water injection. So what you do is you inject water at high pressure into the reservoir, and then you have so much pressure that the oil comes out and the water enters in. So whatever you are taking out, you're filling in with water, and then you are extracting the oil.
No, thank you, because that's a bigger misconception or lack of understanding that we think that oil is extracted. But yeah, so you are filling water and extracting oil. So
Right.
right.
So
Sure.
these are the typical wellheads that we see uh, in the field. What you see on the top is just the wellhead, but when you drill to the reservoir, you can go vertically into the reservoir, which is the easiest, cheapest, simple way to do it. Now that means so there are two things: the where you hit the reservoir, that is called the downhole, where you are drilling on the top surface, that is your top hole. So not necessarily both the holes are aligned, like you see in the second and in the deviated and horizontal. You have your oil is not extracted right beneath the wellhead, so it's deviated, because what happens is sometimes you have oil at a certain distance beneath, and you have a structure over that downhole, so you can't directly access it from the top, so you have to have a way to get it out. So the second technique is called it's the deviated wellhead type. The third one is the horizontal. That's the most complex and difficult to drill, very expensive technology. What happens here is, I'll give you an example. There is a small town called San Ardo, around 30 miles north of Paso Robles on 101 highway. So if you go north 101 on Paso Robles, you will hit a small town called San Ardo. So, and there is a Salinas River going beside it. So the reservoir there has oil beneath the river. So in those situations, horizontal well drilling technology is used.
So what does actually drilling mean, in the sense that what goes into the hole, and what's the process there?
See, what you see here is, it's a typical wellhead casing. So on the top, you see is the surface. Then you have the conductor casing. Then you have the drilling mud. Then you have the surface casing. Then you have the cement, and then the production casing, and then you hit the reservoir. So what basically happens is, when you are extracting oil, you are not extracting oil. You are extracting basically slug, which includes oil, mud, gas. So when you extract it, your your slug comes out from the main well, and then you have the casing gas, which gets out as well. So you collect the casing separately, and then you collect the slug or the semi crude oil separately. So that's why you see a typical wellhead like this. So we won't go into detail, but you have basically collection of casing gas, and then the collection of the actual oil.
Right. So now we can, yeah, better correlate, because we always hear that oil is called black gold also. So it is in the form of crude oil. It is extracted, then it goes to the refinery. So one we see on the in Richmond, the Chevron refinery. So I think it
Right.
gets refined there and sent globally in ships from there.
Right. Chevron has two major refineries in California. One is in Richmond, you mentioned. The other one is El Segundo by the airport. So those are the two refined Chevron refineries that most of this crude oil is sent to.
Ishender.
So I guess this just outlines most of the major disciplines that we see work in the oil and gas sector. Like Surinder explained earlier as well, that there are multiple challenges and it's a pretty technical and hardcore kind of line. So we have multiple people with multiple backgrounds working on these. So Surinder, let's go through each of these, see what they actually do. Kind of relate that to
Right.
what they do.
So basically, as a mechanical engineer, our job is we design the facility, which includes your equipment sizing, equipment calculations, piping design, then your temperature and pressure calculations. All that goes into mechanical. And then you have and process, so both are related, mechanical and process. And then you have the electrical, because then if you have something out in the field, nothing mechanical works until it has power, so electrical is kind of a big part of this whole process. You have your you have to have transformer, you have to have junction boxes, you have to have PLCs connected. So because most of the fields here are automated, so you have to have some kind of electrical and control signals going to them, so we have for the better functioning of the whole facility. Then we have instrumentation and controls engineer. They play a big role. They have all the controls part and all the instruments. For example, if you have a tank, you will have pressure indicator, you have temperature indicator, you have transmitters, you have gauges, you have all kinds of sensors on it. You have all kind of switches on it. It's level switches, high level switches, low, level alarm. So electrical and controls design it in a way so if you have a tank filled, let's say if you have a tank filled with water, and you have a pump extracting water through it, the electrical the instrumentation control, they set alarms which send the signal to the pump when to start, when to stop. So they play a major role in the smooth operation and safe operation. Now in mechanical and process, we also do make sure we have all the safety devices intact, like all the safety relief devices, pressure relief devices. So those are also designing those, and specifying those is also a big part of our day-to-day work. And then comes the project engineering, because as engineers we just focus on the technical aspects of the work. Then you have the project engineers that help you keep yourself on schedule, on time, on budget. They coordinate within various disciplines. They act as engineers as well as they act as project engineers, because they they have general engineering degrees at times, and then they know a little bit of all the industries involved, so they have a better understanding. So they act as a glue, keeping everything together as a project engineering and project manager. Then you have structural and civil engineering. Structural, because once we design a facility, we have all kinds of equipment. You have tanks, you have vessels. You need to have a strong, sound foundation. And California is very strict. You have building code that you need to adhere to. Then you have seismic calculation, because California is very prone to earthquakes, so that plays a major role in structural engineering. Then you have civil. When you design a facility, you need to make sure your roads are paved correctly, your equipment is on a leveled surface, you have proper drainage, you have proper in case of any fatality, you have a proper what they call it, a tank that takes all, that's kind of a safety feature, or everything drains into one low spot. So civil engineering plays a big role there. And of course petroleum engineering is a very specialized field, so they are the masters of everything. They know the reservoirs, they know the geology. They are more of on the chemistry side. the viscosities, they are all on the chemical side of the things.
Right. No, Surinder, if a school or college going student, they are interested in oil and gas, so it is very diverse. So it has lots of opportunities and options. So can
Right.
you please share with us, so like you are in Bakersfield in United States, which areas, which states or locations have the drilling at present going on, where we have
Uh,
more job opportunities?
we have in US, you find Texas is one of the major states that has huge reservoirs. Now there is a small city in Texas called Midland, um, that has recently discovered a big reservoir there, which connects, I think, three states. So it's kind of North Texas, and you connect to part of it goes to, I think, Colorado, part of it goes to New Mexico. So it connects, the reservoir beneath is kind of hitting three states. Then you have oil in Colorado. Then, of course, California plays a major role. In California specifically, you have oil in Bakersfield. Then you have oil in Ventura. By the Ventura is kind of known for beaches, but if you see behind, if you have a beach on one side, you have mountains on the other side. All the magic happens behind the mountains. So it's there is a big reservoir as well. So we have Ventura, we have Arroyo Grande, which is also on the coast. Then you come up north, you have Sanardo. Then you go on five, you have Colinga has a big reserve. When we have here Kern River, so there's a lot of oil present throughout United States. These are your basic oil field processes. I won't go into detail of all of them, but the basic process is, um, we do the oil cleaning, we do the water cleaning, then oil cleaning and water cleaning. Basically, if you are saying you are an oil producer, basically you are a water cleaner, because if you are extracting 100 gallons, 95 gallons might be water and slug and everything else, and maybe 3 to 4 to 5 gallons might be oil. So consider us as oil companies is basically water treatment companies, and they happen to extract oil out of it. So you have oil cleaning, then you have water cleaning, then the water softening is another process, because once you extract the oil and ship it, then the liquid residue left is water. And then then you have to have, if you want to recycle that water, sometimes we have to use them in if we want to recycle it, we soften it. You have the hardened water, we need to soften it. You have sulfur treat vessels. Then you have all kinds of other equipment that you treat the water with, and then you soften it, and then you can use it for steam generation again. Now, like I mentioned before, when you extract oil, it's not the oil, you have casing gas coming out of it. So you and it has California, on a sidetrack, California has, when you extract oil in California, there is a very poisonous gas around here, which is hydrogen sulfide, H2S. So that is a very poisonous gas. So if anybody is in and around the oil field, if you are too curious, don't just jump into the field and see what's happening. It accommodates at low spots, you can't smell it. So and the higher the concentration, the less the smell. So if you can smell it at low concentration, but at the higher concentration you can't even smell it. So be aware. On a side note, in oil field there is a very poisonous gas, hydrogen sulfide. So once you do the casing gas recovery, you extract the gases, unwanted gases out of it, and then you can use the same gas as fuel gas for your various oil operations. You can use it for steam generation, and so on and so forth. Then you have basically you have three type of uh, oil injection processes. You have the basic stream drive. Like I told you, we inject water at times. Sometimes, depending upon how the porosity and your permeability of the rock is, we have to inject steam at high pressures. So once you inject the steam at high pressures, then you recover the oil through injecting steam into the rocks. Now and then there is a cyclic steam. It's a very specialized technique. The cyclic steam, what you do there is you inject the steam at high pressures into the reservoirs, let it stay there for 2 days, 3 days, 4 days, and once the pressure is high enough, the same steam comes through the same infrastructure. So you inject steam through the same well, and you extract oil from the same well. So in our language, it's called huffing and puffing. So huff puff, huff puff. So you inject steam, wait, extract oil, inject steam, wait, extract oil. So that's a very specialized process, and it's very concentrated to very small area here in the Bakersfield industry. Now then we have water injection, like I told you, in Lost Hills we have the water injection process. What you do is you inject water at high pressures and then extract oil out of it. And so you have water wells. You have once with the wells you see, they are various kinds. It can be a steam injector, it can be an oil producer, it can be a water injector, it can be a cyclic steam well. So there are all kinds of different wells. You can tell from the wellhead what kind it is. So these are the basic processes that we have in an oil industry.
So another terminology we hear is fracking. So can you share with us what that terminology means?
Fracking is it has been not addressed properly. Basically, like we explained in water injection process, people think that oil is, you extract the oil from the reservoir and the soil below will sink.
Right.
It doesn't happen that way. It's more complex than that. So California has the strict regulations of all the states, as we already know, in all the industries. So they won't allow that kind of thing to happen. If it's that dangerous, we won't be in the oil industry for so long. So there's a misconception. It's what we take out is what we put in. So it's not that simple that the terminology people say fracking, extract oil and you see a big hole in in your neighborhood. It doesn't happen that way. So knowledge and awareness is very important in those areas. Yeah.
Right. Ishender.
So, what are some of the wells that we see around our California area?
See, like I mentioned before, we basically we have three kinds of wells. You have water injection, you have steam injection, and then you have cyclic steam. So water injection, you inject water at high pressure and loosen the oil reservoir and extract. Steam is the same way. Some depending upon the viscosity of the oil, depending upon the permeability, porosities. Some reservoirs need steam injection, and then there are some very specific areas that need cyclic steam because there is a special layer of rocks in our valley that require that kind of process.
Right.
Thank you for sharing that, Surinder. What is it that you do? So, for people who are trying to get into the field, what does a day in the life of oil and gas engineer look like?
So basically, we are involved. It's a team effort, and on a daily basis, we are interacting with all the disciplines. You name it, we have it. Structural, civil, electrical, process, controls. It all has to come together as a team, because the first thing we do is we generate the P and IDs, which are known as process and instrumentation diagrams. So process engineer is the one that does that. That's part of the feed process. The feed process, what we call is FEED, that is called front end engineering and design. So the first and foremost document that you will create is the P and ID, the block flow diagrams, the process flow diagrams, and then the detailed version of all those is the process and instrumentation diagrams. So process and instrumentation diagrams then is convey to mechanical engineers, to electrical, because and to control, so they give their own input on top of the process. So because controls have to add their part, we have to add our part. What kind of piping are we using? Are we using stainless steel? Are we using carbon steel? Are we using HDPE? Are we using what kind of pumps are we using? Are we using centrifugals? Are we using plungers? Are we using are we using those vertical turbines? So it depends. So we have to make sure those kind of things on a day-to-day basis. Then you have piping calculations. There are various ANSI codes, American National Society of, it's American National Society. So we have various codes there. These are the piping codes: 31.3, 31.4, 31.8 is for the gas. So if you are doing anything related to gas, you have to adhere to the 31.8 process. Then the second is the pump identification and specifications. Though you have to identify according to the process requirements, and your fluid requirements, what kind of pump you want to select, what kind of internals you want to select, what kind of mechanical seals go into it. Is it a self lubricated, or you need an external lubrication? That's another part. You have to add another line to it that lubricates it all the time. So are we doing all stainless steel parts? Are we doing all carbon steel parts? What is the client's budget? What client expects is what we give them, or what we shoot the client with a reality check. The cheap doesn't work all the time. So those kind of stuff, it's mainly interactions. Then you go on the higher side, you have tanks, vessels, compressors, heat exchangers, steam generators. We specify them, we talk to the vendors, we can go back and forth. We make sure we got the right stuff for our clients. Then a big part of this is piping and equipment stress analysis. We use a software called Caesar, which is a highly specialized software used for the stress analysis. The stress analysis by means is, in a simple way, we can say is, for a carbon steel pipe, there is 1 inch of expansion per 100 feet per 100 degrees. So when you have long lengths of pipe, you need to make sure that your pipe expansions and contractions are taken care of, because if it expands too much, if it contracts too much, you have a lot of stress developed into it. The pipe might burst. It might be overstressed at one point, and you might have problems. You will see a lot of noise. You have all kinds of issues. So stress analysis, we make sure the pipe supports are in right positions. And then we have spans for pipe support. For a 2 inch, we have a different span, so that from one support to another support, the pipe can only be that long, so that it doesn't sag, it doesn't have too much stress. And then you have anchors and guides and limits. So you have all kinds of analysis that goes into the stress analysis. We do finite element analysis, FEA. So we do all kinds of that stuff there. And then plot plan creation. Once you have the P and IDs ready, you have a green field. Green field means is you have a brown field. You need to create the an oil cleaning plant or a water cleaning plant. You have to locate the equipment in a way that it's accessible, it's usable, it's practical, it's constructible. So you are not an engineer, you are a designer as well, and you are a construction manager as well, because a design is only as good as long as it can be easily constructed and easily used and easily accessible. So all those kind of things go. And then you have the equipment layout, which is a part of the plot plan creation. And then you have the piping layout. So once you lay the equipment, you have to make sure how you lay the piping. If you're laying it on top, you are laying it on support, you are laying it underground, what kind of road crossings are coming in, how you need to handle the road crossings. Is it a major road crossing like a highway 43 or highway 46 that you need the permission from the city to drill it, auger it, go from one side to the other? So all those kinds of stuff is kind of a daily engineer's day-to-day life.
Sounds pretty
No,
involved.
Thank you, Surinder. Yeah, so now we understood what a day-to-day life of a mechanical engineer is. So from the software perspective, because we are in the Silicon Valley, and right now school or college going students, they have to have the information or knowledge of some kind of software. So what
Right.
kind of software opportunities are there which they can learn and choose this career?
See, for engineering, design, and drafting, we have AutoCAD. Then we have CADWorks. AutoCAD is 2D, and then you have CADWorks is kind of 3D modeling. I would highly encourage new people who are joining this industry or any industry that needs these softwares. Learn the 3D. That is the way to go. It's kind of it's a good interface if you want to show something to the client. It's easy to go on the laptop, put it on a projector screen and tell them, okay, this is what we are doing. So the construction managers, the field engineers, they understand 3D more than a 2D, and then of course you extract 2D drawings from the 3D. So SolidWorks is another 3D good software for equipment designing. Then these are the latest ones, the PDMS and the Viva. These are very highly specialized and technical softwares for mechanical designers. They are available for electrical designers as well these days. So the idea is, if you want to be in this field, you don't necessarily have to be an engineer. You can be, if you are computer savvy and you are learning softwares. So if you are a good AutoCAD operator or a CADWorks operator, within a few years you can become from an operator to a designer. So
Right.
it's part of the building process. And then for process modeling and steam simulation, which is very important, we need to see the pressures and temperatures and all the behavior of various fluids, how that is taken care of, how that behaves in the field, what conditions do we have. So and some of the pressure drop calculations we do in these softwares, some of the equipment sizing we do in these softwares. We have pipe phase, pipe flow, HISIS. HISIS is highly specialized for steam modeling, and then pipe flow and pipe phase can be used for process modeling. Then for Caesar, I mentioned, we have for stress analysis, we have Caesar 2. That's the latest version. So that's what we are using for piping and equipment stress analysis. Where we need a support, where we need to distribute the stress, where we have to make sure that the stress is not too much on a nozzle that it damages the equipment. So all kind of those factors go in there. And then for calculations, we use a software called MathCAD. Very easy, very simple to use. If you know your calculations, it's just a matter of putting them in there, rather than on paper. You just put the formulas in there and it automatically decodes everything for you. Very, very useful and very handy. I have been using that for a while. So that is for calculation purposes.
Sure.
So what are some of the other careers for oil and gas industry other than, say, engineering, which we sort of discussed? And I guess the first one is engineering. Good.
Right. The thing is, a total misconception is that only the major fields are involved in engineering. Now, uh, there are you can be a facilities engineer. You can have you don't have to have a mechanical background. You can have a production background and still go into production engineering, right? Then if you are not engineers and still want to be in this field, you can be a mechanical designer, you can be an electrical designer, you can be an instrumentation and controls designer. Every engineering field requires design. Though you can be a structural designer, civil designer. So though you have all kinds of opportunities there. And if you want an interface between project management and engineering, you can be a project engineer, be on the technical side and also be on the management side. So you can be the boss of both worlds. Then you have the construction manager. If you if you don't want to be a desk guy 8 to 5, I don't want to be sitting on my desk the whole day, I need some field work, then go into construction. You can be a construction engineer, you can be a construction manager, be in the field, learn, be hands on. So you can build things from the designs, what engineers and designers provide you from the drawings. Construction managers and the construction crew is the one that's actually building it. So you can be on the field for that kind of job. And then of course, like our chief says, there's nothing a mechanical engineer can do that a process can't. So the process engineering is another venue. If your chemistry is strong enough, you have the basics right, you can be a mechanical engineer and process engineer. So you if you and then you have chemical engineers that mostly do the process work. So there are all kinds of opportunities in there. You can be a PLC operator. You can be you can be in the controls room. You can be the plant manager for supervising everything that goes on in the plant. So there are various fields that you can go into. You don't necessarily have to be an engineer.
No, thank you very much, Surinder. So we learned about oil and gas industry, so how wide it is, and from 1930 to 2020, how it's increased exponentially. Lots of options, opportunities that we have in it. So now request Ishinder if you have something in mind to ask Surinder.
I think just going over to through the presentation, what I want to stress was that we really digged into all the engineering fields and all the processes around it. But the overall theme is it's a very large industry, and I think anybody who is trying to get a job in this kind of role, you guys can definitely look into it and reach out to any of us through our emails to get more details.
Yeah, so Surinder, so for a school and college going student, you have bachelor's, master's, and approximately 15 plus years of experience in the industry. So what's your
Yes.
suggestion to those students who are interested in oil and gas industry?
See, there is no lack of opportunities. You just have to be a good learner. Uh, if you have a technical aptitude, you can excel in this field. Like popularly, some people say, like my chief says, he's more of a mentor to me. He will say, I don't know what you know, but I definitely want to know what you don't know. So, they can help you out. And this industry is so cooperative. Even when I joined as a young engineer like 10, 11 years ago, and even now, if I have a question, nobody questions me back. Hey, you have been in this industry for so long, how the hell you don't know these things? It's kind of okay. If you don't know, you don't know. Just we are here to help, and if we know something, we will pass on to the next generation. So I would highly encourage people who don't want to sit on their laptops, computers 8 to 5. This is a very exciting, challenging field, a mixture of on field and on site and in office job. So it's very exciting.
No, thank you very much, Surinder. Yeah, the main key point you mentioned, never stop asking questions. So you have to be asking questions all the time. And thank you for sharing what kinds of opportunities, options, and routes we have in oil and gas industry. How a school and college going student who is interested to join this industry, what kinds of options they have around them. And to our viewers, thanks for watching, and please do send us questions. We will pass it on to Surinder to get them answered, and provide us feedbacks and suggestions for the topics you want to listen in the future episodes. So see you in the next episode. Stay healthy and stay informed. Thank you, Surinder. And thank
Thank
you,
you,
Shiv.
guys. Thank you.